Welcome back, and in this video we're going to look at quadratic functions, and maybe it's a good time to actually say, okay, well, quadratic, we've heard that term before, right? We've talked about quadratic equations, and there was a quadratic formula and all that stuff. If you need to look up the quadratic formula, please do. But when we looked at a quadratic equation in standard form, we looked at something like 0 is equal to ax squared plus bx plus c, right? And we also had the condition that a, b, and c are real valued parameters. Parameters is just a placeholder for a number, and then a is not 0, because if it was 0, then we just get a linear equation, and that's boring. Okay. Now, when we kind of switch our perspective from equations of functions, really, when we use the language of function, again, it's for every x value, there's exactly one y value, right? Vertical line passes all that. Okay, so a quadratic function, or what we call a second degree polynomial function, really is just y is equal to ax squared plus bx plus c. So really, instead of 0, we have y. Okay, so 0 was a particular value of y. Okay, and so more generally, we just use the notation f of x is equal to ax squared plus bx plus c. Okay, so then again, if you're given a particular value of y, then we can solve this equation. And what methods can we use? Well, let's see, we have the quadratic formula, our favorite friend. We could also try factoring, or the square root method. It depends on the equation and the context, but maybe revisit, it was section 2.3 from our textbook if you wanted to review kind of the methods to solve quadratic equations. But I'm going to say we know that and we're well versed in it. Okay. Now, just like we had linear equations came in a variety of forms, right? Slope-intercept, point-slope, standard. Well, the equation that we have up here, this is really what we call standard form. Okay, and certainly the condition a is not equal to 0 applies, and then bx plus c are just numbers. Okay, but in addition to this form, there's two other forms. There's factored form. So again, if it happens to factor, there's an a value that we could factor out front, and that would be like the GCF, and then R1 and R2. And R1 and R2, we will come to call these the horizontal intercepts or x-intercepts. Okay, so that's why this one's really nice. We get the horizontal intercepts for free. Okay, and then, so this is factored form. The other one that is extremely useful, but sometimes hard to get to, is called vertex form. Okay, so we have parameters. So a is kind of that GCF idea, so it's a factor that we factor out, and then x is our variable that we're looking at, and h and k are what we call parameters, and we also recognize h and k as the location of the vertex, and so that'll be something that we talk about in the next video. Okay, but so we have these three forms, and all I want to do right now is to hop onto Desmos and play. So I'll give you a demonstration. If you want to do it on your own computer, you're welcome to, and I have it pulled up here. Okay, so I have standard form shown here. Okay, and then when you type this equation in, it'll tell you, oh, do you want to make sliders for A, B, and C? And then you click yes to all. Okay, and so now all we have to do is kind of look at changing these. What happens? Well, as we change A, if A is positive, it gets, it opens up, and there's this general shape of a U type shape. And then as we get to be 0, there's our line, right? And then as we go negative, it sort of reverses. And then as it becomes a larger negative or a larger positive number, it gets super skinny. Okay, so that's kind of the effect that A has on it. If we look at B, B looks like it's just kind of moving side to side, okay, up and down. So it's kind of moving along a U-type shape. Okay, C, I think that's just going to move it up and down along the vertical axis. Okay, so the combination of B and C can move it depending on where it is in space. So it can move, B can move it up and down and left to right, and C just moves it up and down. Okay, so that's standard form. If we look at the vertex form, okay, again, I have this all plugged in. I'm going to leave A fixed at 1 just because it's easier. So for the remaining ones, A is at 1 for all these. And then R1, so R1 is just going to kind of move it side to side, and I think R2 is going to move it side to side as well in a little bit. Okay, so they kind of just move positions in space here. Okay, but what you notice is, let's say I get this at -1, if I can do that here. Okay, -1.1-ish, and this is at 4. Okay, if I look at the x-intercepts here, I get 4, which comes from that first root, or from that first R1, and R2, okay, imagine that was like -1. It would cross right at 1. So it's a little off right now because I can't get the slider right to -1, but you get the idea. And the last one, the vertex form, okay, so if you notice, we have A fixed at 1, okay, H and K, so H and K are both set to 1, 1. It just so happens that if we look at the point 1, 1, that's this bottom of the graph here, okay, the minimum value, that's where the minimum occurs, okay, and then so you can imagine H, what do you think H does? Well, H is actually just going to move it left and right. So if H is positive, that is when it moves to the right, and if H is negative, that's when it moves to the left. So the minus here is important, and it's always kind of opposite of what you think. So if it's a -1 in there, that actually means that H is 1, and it's going to be over to the right side. Okay, and K is a little bit more straightforward, but instead of going up and down, or left and right, it goes up and down. Okay, so if K is positive, it goes up. If K is negative, it goes down. All right, so that's a little bit of exploration related to quadratic functions and their graphs. In the next video, we're actually going to produce the graph.